So if I tried this, the inverse sine of 1.3, it tells me undefined. Okay, now let's take a look at what this sine ratio represents. Remember, you can always model it with a right triangle. So if I sine this my theta angle, okay, and I want my ratio to be 1.3, that means my sine ratio, opposite over hypotenuse, has to be 1.3 over what? 1. Does this make sense? What's wrong with it? Good. In a right triangle, the longest side's always going to be hypotenuse. So the leg can never be like that. So what restriction would have to exist on any sine ratio? Can't be over 1. Okay. What about cosine? Same thing, right? Adjacent over hypotenuse. So the one thing to keep in mind is sine and cosine. These are always going to fall between two values. 1 and, now you guys have started to see the unit circle. Okay, think about what that unit circle represents. Okay, remember, the sine and the cosine are which coordinates? X and Y. So what's the furthest to the right your cosine or x value can possibly be? No, all the way here your cosine is 1. Right? This is the point 1, 0, cosine 1, sine 0. What's the furthest to the left your cosine can be? Negative 1. Right? It can go all the way here to negative 1. Hey, what about sine? What's the highest your sine can possibly go? 1, right? Hey, and then what's the very lowest your sine value can ever go? Negative 1. There you go. Oops. So 0, negative 1. Okay, and so looking at that, or at least what the unit circle models, is this restriction. And so anytime you're taking the inverse cosine or the inverse sine, you know that it has to stay within those. So can you take the inverse cosine of 1? What would the answer be? Oops, I wrote this one up here. This is 0 and 1. Okay, so when you're looking at an inverse cosine of 1, what does that equal? Zero. Cosine, if it's asking you for a ratio that's higher than 1 or lower than negative 1, it's not going to work. Hopefully you kind of see why. It'll cycle it back here. All right.